Hi class, this is Mr. Krieger. It's my attempt to teach you through videos. We're going to start on the next unit, which is on the chi-square distribution. So it's unit 14, lesson 1. How do we use the chi-square distribution to determine goodness of fit? Just so you know, there'll be multiple videos to this lesson because it's kind of a longish lesson, okay? So just check to see how many videos you have to watch. All right, so let me explain to you what this distribution is all about. Here's an example. Are the M&Ms in a bag distributed the way that the M&Ms company claims that they are? The company claims that in their bags of M&Ms, 13% are brown, 13% are red, 14% are yellow, 16% are green, 20% are orange, and 24% are blue. Now, even though this is the distribution of M&Ms, we expect a little bit of variation. If we got 14% brown in one bag, that wouldn't be too crazy, but if it was 30%, then maybe there's something wrong. So we go out and buy a bag of M&Ms, and there are 57 M&Ms in there with the specific values 7 brown, 6 red, 7 yellow, 13 green, 8 orange, and 16 blue. And we want to see if the bag is distributed the way the company says they're distributed. Now we're actually going to solve this problem later. I'm going to actually pick a different problem to do first. Before we pick that problem, let me just tell you a little bit about what you need to know. Now we're not going to go through this stuff in full detail now. We'll do that later, probably in the second part of the video, in the second video, but let's just talk about what the chi-square distribution is. First of all, the chi-square distribution is not normal. It's a skewed right distribution. We're going to need a degrees of freedom for it. It's computed in a different kind of way than we've computed degrees of freedom for the t distribution, okay? There are two types of chi-square tests. One involves a two-way table. We'll actually look at that in future lessons, lesson 2 and 3. Today we're focusing on the goodness of fit, which is actually like a one-way table. I'll show you what I mean. Here's a one-way table. It's just a particular distribution of outcomes of something, a particular variable. This is the one we're going to look at in a couple of minutes. So that's what you're looking at, a single distribution of data. And we'll talk about what you're testing in a few minutes. So with the goodness of fit test, you're using it to help you to determine if a population, I'll put it in my own words, if the distribution that is expected is the same as the distribution that you observe. Okay, this is the calculation you'll do. Maybe we'll do that in one of the later videos. A couple of things you need to know for the conditions. I'll tell you how to find a normality condition, but you do need to have an SRS. That's one of the main things, and there's only one other condition that you're going to have to check. We'll take a look at that later, but it won't make so much sense unless you appreciate what we're trying to accomplish. So let's take a look here at this problem, which we'll work through. Auto accidents in cell phones. Are you more likely to have an accident when using a cell phone? A study of 699 drivers who were using a cell phone when they were involved in a collision was used. Here's what we have. The drivers made 27,798 cell phone calls during a 14-month period. Each of the 699 collisions was classified in various ways. Here are the counts for each day of the week. So there were 20 accidents on Sunday, 133 on Monday, 126 on Tuesday, etc. Now, what we're going to do is we're going to say, well, you know what? I wonder if, well, my expectation is that accidents should be uniformly distributed. There should be the same amount of accidents every day of the week. You can disagree with that, but let's say that's what our expectation is. So what we're going to do is we're going to take the 699 number, total number of accidents, divide that by 7, and that will give us the expected number of accidents every day. If you're expecting the distribution to be uniform, and that is to have the same number of accidents every day approximately, then of 699 accidents, 99 should happen every day of the week. Now, when you look at these counts, you see that's far off, but that's because you notice it's probably not true, but the test will tell us for sure whether it's true or not. So it looks like on the weekends there are far less accidents. In the middle of the week, there's a lot more accidents. So how do we actually do this? First of all, our null hypothesis is always what we expect. There's really no difference between accidents on any particular day of the week. This is how you would write it. Same number of accidents every day of the week. The proportion on Sunday is equal to the proportion on Monday, is equal to the proportion on Tuesday, etc. And the alternative will be, no, there's at least one of these days, or probably more than one of these days, is different than our expectation, okay? And I will actually show you how to make the chi-square statistic without a calculator, but right now, I think we'll do it with the calculator just so you can see how this works. So what you want to do is you want to go to stat, tests, and go down to the GOF test. Let's take a look where it is. Chi-square GOF, not C, but D. We're going to put that in. We're going to have to put the data into the calculator. I'll show you how to do that too. And the degrees of freedom, I'll tell you how you do that right now. So for the degrees of freedom for a goodness of fit test, look how many categories there are. Since there are 7 days a week, 7 categories. The goodness of the degrees of freedom for this is the number of categories minus 1. So our degrees of freedom is going to be 6. And I'm going to put the data into the calculator.